Hello everyone, welcome to my channel Physics with Bhatt. To learn concepts of physics, subscribe this channel and press the bell icon button to get notified for every new video lecture. Dear students, good morning to all. Hope you all are doing good. Today once again I am here with you with the new video lecture. In this lecture, we will discuss about intensities of fringes of interference. In the last video lecture, we discussed in detail about the pattern of fringes obtained on the screen in Young's double slit experiment. There we had seen the positions of fringes, at what position the bright fringes are formed, and at what positions dark fringes are formed. That formula I have taken here also. The bright fringes are formed on the position n lambda d upon d, where capital D is distance of the screen from the plane of slits and a small d is separation between the slits. If you place n is equal to 1, you will get first bright fringe. If you place n is equal to 2, you will get the position of second bright fringe, and so on. Similarly, on some other places, dark fringes or dark bands are seen on the screen. The positions of dark bands in general are given by y dash n is equal to 2n plus 1 lambda d upon 2d. If you place n is equal to 0, you will get the position of first darkness, that is lambda d upon 2d. If you place n is equal to 1, you will get the position of second darkness, that is 3 lambda d upon 2d. If you place n is equal to 3, you will get position of next dark fringe accordingly. Then we discussed about the width of fringes, and the conclusion was all the fringes or bands are of same width, and that width is given by beta is equal to beta dash is equal to beta node is equal to lambda d upon d. So it is irrespective of bright or dark or central bright fringe, all the fringes are of same width, and that width is lambda d upon d. In today's lecture, we will talk about intensity of all the fringes, and that is also found to be same. How can we understand this in proper way? That you will see in the remaining section of this lecture. To understand the fringe pattern on the screen, I have taken two diagrams here. The first diagram is the experimental arrangement of Young's double slit experiment, and the second diagram is exclusively about the positions and intensities of the fringes obtained on the screen. You can see in this first diagram, we have a single slit which is acting as monochromatic source, and this single slit is illuminated by the source of having the single color light. The light passing out of this single slit is illuminating two slits which are here, S1 and S2, and the waves originated from these two sources are superposing, and we are getting the fringe pattern of the interference on the screen. That you can see the blue lines are shown here. Just below this arrangement, you can see the brightness of the fringes. All the white lines are representing bright fringes, and all the black lines are representing dark fringes. So it is very clear from the first look of this diagram that all the fringes are of equal width. That you can see here, the width is same, and the brightness is also appear to be same. To understand this in detail, I have taken a graph here. That graph is interpreting both width, position, and intensity. You can see in this graph, O is center of the screen. At the center, bright fringes formed, and we had discussed in middle of this lecture that all the fringes are of same width. That you can verify from this diagram also, because it is interpreting the same results in this graphical pattern. So center of the screen is denoted by 0. If we talk about the first dark fringe after the center bright fringe, the position can be obtained by using this formula of dark bands. If you put n is equal to 0 in this formula, you will get 1 0 plus 1 into lambda d upon 2d. So it comes to lambda d upon 2d. Just see here, this is the position of first arc, lambda d upon 2d. Then it comes to next bright fringe. The position of bright fringe is given by n lambda d upon d. If you put n is equal to 1, you will get first bright fringe, and the first bright fringe will be lambda d upon d. So that you can see here, it is lambda d upon d between lambda d upon 2d and 3 lambda d upon 2d. That this position would be lambda d upon d, and lambda d upon d is representing bright fringe position. Then it comes to second arc is 3 lambda d upon 2d. How can we get this? If you put n is equal to 1 here, so 2 into 1 is 2, 2 plus 1 3, 3 lambda d upon 2d. This will be the position of the second arc, and you can see here in this graph also 3 lambda d upon 2d is position of second arc. Then it comes to position of second bright. If you put n is equal to 2 here, you will get 2 lambda d upon d, and that 2 lambda d upon d is the position of second bright. In the same way, we can get third dark also. If we put n is equal to 2, you will get 2 into 2 4, 4 plus 1 is 5, 5 lambda d upon 2d. So this position is third dark position. In the same sequence, we can go for more number of bands or fringes away from the center of screen in the successive numbers. The same pattern is obtained on other side also, and that is denoted by negative positions. So minus lambda d upon 2d is the first arc on opposite side, lambda d upon d is first bright on opposite side, 3 lambda d upon 2d with negative sign is second arc, and so on. We can place the fringes. Now you can see one more aspect of this, or rather I should say two more aspects are possible of this representation. This graph is illustrating about the distance from center of the screen and positions of the bright and dark bands. We can have path difference as well as phase difference also. So when it comes to path difference, the center bright fringe will have zero path difference. All the waves will reach in the same, you can say, same path, so no path difference will be considered there, and they are producing brightness. When it comes to first dark, the path difference is lambda by 2. If we talk path difference, then for path difference lambda by 2, phase difference would be pi, because for lambda it is 2 pi, so for lambda by 2 it is pi. Then next would be lambda. So for lambda we will get the first bright, so after lambda by 2 next position would be lambda, and for lambda path difference the bright fringe will be obtained. Next is 3 lambda by 2. For 3 lambda by 2 again the dark fringe is obtained, that is the position of second. So in that way you can go for the higher order fringes also, like first, second, third, fourth in both bright and dark segments. So there are two more possible representation. If you place this path difference, then it will start from 0, lambda by 2, lambda, then 3 lambda by 2, 2 lambda and 5 lambda by 2. If you talk about phase difference, then you will have on the x-axis 0, pi, 2 pi, 3 pi, 4 pi, 5 pi and so on, and these would be the positions of dark, bright, dark, bright, dark, bright and so on. So one thing is very clear, intensity of all the fringes is same here, that is represented by this graph also. You can see in this graph the pink color is used for representing bright fringes, and this gray color is used for representing dark fringes. So these fringes are obtained on the screen in that way. So intensity of all the fringes is same, that is all the bright fringes is same, and that of all the dark fringes is also same. Now we will talk about a little topic here along with these intensities, and that is angular width. Angular width of the fringes is given by theta is equal to beta upon capital D. Here beta is the linear width of the fringes, and capital D is distance of the screen from the plane of slits. So if you replace for beta, beta is same for all, that is lambda d upon d. Upon d, if you simplify it, you will get theta is equal to lambda upon small d. So angular width of the fringe is given by lambda upon d, and linear width is given by lambda d upon d. Now we have to understand what are the factors affecting the width of fringes. If we analyze these two mathematical formula, then it is very easy to understand that what are the factors. The first factor is capital D. The second factor is small d, which is distance between two slits, and capital D first factor is distance of a screen from the plane of slits, and the third and very important factor is the wavelength of light used. So we will take them one by one. The first factor is distance of the screen from the slits. Uh, since angular width is independent of capital D, so there is no effect on angular width. It means wherever we put the screen, we will get the fringes of same angular width at all the locations. But when it comes to linear width is directly proportional to capital D. If capital D increases, then linear width also increases. If capital D decreases, then linear width will also decrease. तो डिस्टेंस का स्क्रीन का डिस्टेंस चेंज करने से फ्रिंज की विड्थ बदलती है. अगर हम स्क्रीन को नज़दीक ले जाते हैं तो फ्रिंजेस की विड्थ कम होगी, और अगर स्क्रीन को दूर ले जाते हैं तो फ्रिंजेस की विड्थ बढ़ जाएगी. द सेकंड फैक्टर इज separation between slits, that is a small d. In both the formula, whether it is angular width or linear width, the small d is present in denominator, so these two are inversely proportional to small d. It means if small d is increased, then the angular and linear width will decrease. If small d is increased, then definitely they will decrease. If small d is decreased, then the angular and linear width would be increasing. So these are the two factors. The third factor is wavelength of the wave. Both the angular and linear width increase with increase of wavelength because they are directly proportional to the wavelength of light. If wavelength of light is decreased, then definitely both linear and angular width would also decrease. If we are having the increased value of wavelength, then both angular and linear width would increase. The example we can consider here is, if somebody is using red color of light, then the width would be maximum, and if somebody is using the violet color of light, then width angular and linear of the fringes would be minimum. So in this conceptual part of the video lecture, we tried to understand about the intensities of the fringes, and we found that the intensity of all the fringes is same. Then we discussed about angular width of the fringes and linear width of the fringes, how these two are affected, or how what are the factors affecting these two. The very important factors are three: small d, capital D, and lambda, that is distance between slits, distance of a screen from the slits, and wavelength of light used. So I hope you enjoyed the learning throughout this video. We will meet very soon in the next video lecture. Till then, keep watching, keep learning.